Well, welcome to the second module on forecasting. What we're going to cover today is satellite information. In the previous module, we covered surface features such as fronts, high pressure, low pressure, and now we'll move on to cloud cover and some things that we can infer from what we call satellite imagery. One of the new links I've added recently, if you go to your Oceans and Atmosphere page here, and since we're dealing with forecasting, let's go ahead and click on weather links here. And from there I've added a module, or actually a web page called Forecasting Checklist. If you click on that, this is a nice site. It's a general forecasting checklist, and you should spend some time becoming familiar with this. But what we'll take a look at here in the next few minutes is satellites. We'll take a look specifically at satellite imagery. There are three types of imagery that we'll be dealing with in this particular class. One is visible satellite imagery that I'm highlighting right here, trying to highlight. And visible satellite is just what it implies. It uses the sunlight to reflect off the clouds, to show clouds, and so visible imagery is nice to use during the daytime, but when it's nighttime, visible imagery is useless. At that point, you have two options: infrared loop, or I should say infrared satellite imagery. And we've talked a little bit in terms of radiation and what infrared radiation, those are the longer wavelengths that make up the spectrum. And also, at night or anytime, we can use water vapor. Now, I should say you can use infrared and water vapor 24 hours a day, because with infrared it depends upon the temperature of the cloud. Recall that anything that has a temperature emits radiation. It also absorbs radiation. Water vapor also is reflected in imagery. So we will take a look at a few of these. Let's go ahead and look at infrared here just for a moment. This is the UNISA site, and what we're doing right now is we're going to look at a 12-hour loop of infrared satellite imagery. And you can see the general movement of the cloud patterns is from west to east. I'm going to identify Iowa here with the cursor, and notice that some of the whiter areas, which indicate cloud cover, over just to the north of us in Minnesota, and then back here in the southwestern portion of the U.S., and then we have more cloud cover coming in from the northwest. So as I sit here on a Wednesday evening over Iowa, there's not too many clouds out here. There's a little bit of middle clouds moving into Iowa. But it looks like as we head into the next day, we can expect to see some cloud cover moving in. So if you were forecasting for Des Moines, Iowa, you would probably venture in your forecast to say that cloud cover will be present, probably tomorrow. We see also some cloud cover down in the southeastern portion of the U.S., but a large portion of the central and southern plains is cloud-free. So, if we were to go back and look at a surface map, recall the surface map is where they have all the low pressures, high pressures, fronts. There's probably some sort of weather system out here where I'm outlining with the cursor, and probably some sort of weather system down here in the southwest, and probably a weather system up here in the Pacific Northwest. So let's just go to the UNISA's homepage, and the first map we see here is a surface map. And sure enough, you see what we call a cold front back here associated with all of these clouds. Okay, so near the fronts and near the low pressure systems, we have a large area of cloudiness. Notice over here in the southeastern U.S., we have high pressure. And typically with high pressure, you see clear skies, fair weather. Now, notice how I'm moving the cursor. I'm moving the cursor clockwise around the high pressure. That is the wind flow around high pressure. So, where would you expect the winds to be coming from in Iowa? I'll try to slow the cursor down. The winds are coming from the south. And we do wind direction by where the winds are coming from. So we have a southerly wind. So by looking at the surface map, I can predict our wind direction, or at least I can surmise where the wind direction is coming from this evening. Now around low pressure, winds are counterclockwise. So around this large area of low pressure, winds are moving counterclockwise. Again, winds coming from the south, southwest, out ahead of this system into Iowa. So if winds are coming from the south or southwest, we would probably expect temperatures to be somewhat mild. And in fact, you see here on the surface what we call a warm front. And this warm front will continue to move to the northeast. But there is a cold pool of air up here in Canada, as we'll see here in a few minutes. So our weather is probably going to go downhill as we head into the next couple of days. Well, let's go back to the satellite imagery. Now again, here's the loop of the infrared. Now what we mean by infrared, these clouds, these high clouds, as indicated by the whiter shade, are emitting infrared radiation. The satellite that is in geosynchronous orbit with the Earth is picking up the emission of the clouds. And so the higher clouds are typically indicative of colder clouds, and these lighter colored clouds here are probably what we would call low to middle clouds, because they're not as white as these here that I'm showing up here in the upper Midwest, or certainly not as white as the clouds we see down here in the desert southwest. Well, let's back up and take a look at water vapor. Water vapors. Okay, going back to the forecasting checklist, let's move to the water vapor loop next. Now, water vapor, again, this is the Unisys site. Water vapor looks somewhat similar to the infrared satellite imagery. However, the features are a bit more striking in the water vapor loop. You will notice areas of darker color and lighter color. The darker areas correspond to drier air. The lighter colors correspond to moist air. You can also pick out circulation features in water vapor imagery, and we'll talk about later why circulation features are so critical to forecasting the weather. But one of the first features that catches my attention is this dry air that's moving off of the Rocky Mountains across Kansas and into Missouri. But notice right behind that dry air we begin to see some very moist air beginning to move into areas of southwestern Kansas, up into the Dakotas, Minnesota. We have a little bit of moist air over Iowa too. Also notice this area back here in the Pacific Northwest. I'm going to take the cursor and I'm going to show the motion of the water vapor. Notice that we have kind of a counterclockwise turn to the features, or at least to the water vapor imagery. This is indicative of what we call low pressure. Recall that winds around low pressure are counterclockwise. So we have a low pressure area that's showing up here, or at least the circulation pattern of a low pressure area here in water vapor imagery. You don't need to worry so much about that. The thing that I want you to get from this particular image is that the lighter or the whiter areas indicate moisture and the darker areas indicate drier air. So we see quite a bit of moist air back to our west, moving into Iowa as we go through the next day. Now the next image we'll look at, we've looked at surface features, we've looked at satellite. Let's look at radar. And you're all familiar with radar. It's areas that denote precipitation, either in the form of rain, sleet, snow, thunderstorms. a myriad of conditions. But you see that most of the U.S. is showing a lack of precipitation. We see precipitation back here in the Pacific Northwest. We also see precipitation back here in the Southwest, and it corresponds to all that cloud cover we saw on the previous satellite imagery. And over here in the middle portion of the country, not a whole lot going on. A few spotty showers, or actually this is probably some snow showers, downwind of the Great Lakes. So this is another type of map that you can use to help you with your forecasting, especially with precipitation, is radar. Now, on a later module, I'm going to talk about features above the surface. We have different levels in the atmosphere that we can look at, but we'll save that for a different module.